Hi, welcome to my online classroom. This is going to be on composition of functions. There is a relationship between y squared, hold on a minute, I've already made a mistake here, easily fixed. There is a relationship between y equals x squared and y is equal to the square root of x. So remember that x squared is the same thing as the square root of x, and that's really important here when you start talking about composition of functions. So I'm going to do a couple of sample problems. So if you want to take notes, you can pause the video, you can do whatever you need to do, and you can replay the video. So I often erase the screen completely so I can start on a new problem. So I'm going to be working on page, I believe it's 197. I'm going to do problem number 27. So I'm going to clear this screen. And the problem that I have is f of x. We're going to let f of x be 3x minus 5. And we're going to let g of x be 2 minus x squared. Now what you want to do when you're finding, I think on the first one for A, it asks you to find f, the function given the input of g of O. So you always want to make sure that you're solving for this inner function first. And at this point, f of g of O, we're going to solve it by putting in O. So you're really saying, okay, I want f of g of x. So go find the function for f, which is let's see, no, we're not going to find the function of f. We're going to find the function of g. And we're going to input that. We're going to take the function of g, which is 2 minus x squared. And we're going to put 0 in the place of the x. So f 2 minus 0 squared. And solve that. And 0 squared is 0, and 2 minus 0 is 2. So in this case, f of g of O is the exact same thing as f of 2. And you can say, and so what you want to do now is take 3 and go back and get your function for f. Now that you know that g of x, f of g of O is 2. So you're saying 3, and then you're putting g of O here, the value that you got, minus 5. Notice that I'm putting that into this x function. I'm actually putting the value that I got for f of g of O. When I got 2, that's the same thing as this. So now I'm going to go back and evaluate my f function for a value of 2. And so I simply put 3 times 2 minus 5, and I get that function, same thing as f of g of O, is going to be equal to 1. And so you're going to get a different answer every time you evaluate it. If you evaluate for f of g of O, that won't be the same answer as when you evaluate for g of f of O. Alright, so let me see if I can page through this. I don't know if I can go to another page or not. No, awesome. Okay, so this is going to be B. And now I'm going to evaluate for g, the function of g, given the input of f of O. And so I need to evaluate for that one. So I will get the f function, which we said was 3x minus 5. And I'm going to move it up here because I just think it makes more sense up here. So I'm going to evaluate that, and if I put 0 in the place of this x, then I will be evaluating this f of g of o, and its value will be negative 5. So that means that g, the function of the value of g at negative 5, these things are the same. They're equivalent to each other. At this point we know that they are the same. So I'm going to say, alright, now I'm going to use that negative 5 and go back and evaluate g of negative 5. So I'll get the function for g, which was 2 minus x squared. That means that I'm going to put that negative 5 in the place of that x squared. 2 minus negative 5. Make sure you're paying attention to your integer rules, because this is a great place to make a mistake. And now you'll have 2. Negative 5 squared is positive 25, so you'd have 2 minus a positive 25. So this function will evaluate for negative 23. So at this point we know that g of f of o is equal to negative 5, which is the same thing as g of negative 5. And you can substitute that negative 5 into the g of x function. Alright, so let's do another one. Let's just go to another page. I'm about to get the hang of this. Okay. Alright, so this is going to be number 23 from your textbook. And this is, I'm going to evaluate the function composite of g. That's what FOG means. The function composed of g. And I'm going to do that when x is negative 2. And they give me a function of f of x. We're going to let f of x be 3x minus 5, and we're going to let g of x equal 2 minus x squared. Alright, so for A, section A, they remember that f composed of g at negative 2. So I'm going to have to find f of g of x. That's the first thing I'm going to do. I'm going to go get the function for f, and I'm going to input in the place of x the function of g. So I'm going to start with 3, and instead of the x right here, I'm going to put g of x, because I want you to see exactly how you're substituting in here. Alright, now, since we know that we're letting x be 2 minus x squared, we're going to put in 3 times 2 minus x squared minus 5. Now, this is distributive property, so 3 times 2 will give us 6. And 3 times negative x squared will give us negative 3x squared minus 5. And if you put your like terms together, a positive 6 and a negative 5, you'll get negative 3x squared plus 1. Now, since we know this, we can now evaluate it with when f is negative 2. So this is a new substitution, but we're going to keep the same f function, which is multiply by 3, subtract 5. So we'll put in negative 2 in the place of the x, plus 1. And so follow order of operations. Negative 2 squared is 4. Negative 3 times 4 is negative 12 plus 1. And that will give us a value of negative 11. Alright. Now I'm going to go to the next page and we'll do the second part where they want us to find g of f of x. Alright, now we're going to find, this is the B part, where they want us to find g of f of x. And then I'm just going to make sure I'm writing my functions up here because I have to use those every time. I have f of x equals 3x minus 5. That part doesn't change. That was given to us in the textbook in this problem. This is problem 23. And then our g of x equals 2 minus x squared. And we have g of f of x. And I'm going to go get my g function this time. And put 2 minus my f of x will go there, and then I'll square it. So notice that in the place of this x right here, I'm putting that function f of x. So now I have 2 minus, and put the whole thing, and make sure that you keep it in a parentheses. Make sure that you always keep your variable in a parentheses when you're substituting. It'll help you follow order of operations. It'll help you remember integer rules. Therefore, you won't make a mistake. Alright, so here's our function. Now that we have a function here, what we're doing is we're putting these two functions together. And so now let's evaluate it for when g, the function of g, has the x input of negative 2. So 2 minus 3 times negative 2 minus 5. Oops, let me change that. Put a bracket around that because that needs to be squared. Okay, so we have 2 minus negative 6 minus 5. And square that. And this gives us 2 minus negative 11 squared. 11 squared is 121. And sorry about that. 2 minus 121 will give us a negative 119. Alright, now let's try a different type of problem. Always ask yourself, what function are you substituting? And sometimes it's really helpful if you write where that function's going to go in there, you'll know which one to choose to substitute. This is going to take some practice, and you really need to work these problems from your textbook. Okay, let's do another one. Oh, wait, I don't want to clear this slide. I want to go to the next slide. Alright, let's do 25. And this is what I always call fog. It's the function composed of the function g, and this is the way it's written in the book. Fog of x. And then they also want you to do g composed of f at x. And so I call that golf of x. It's been a long time since I've done fog and golf. Alright, so let's do the first one over here. We're going to do f of x. No, wait. Let me rewrite that. we'll do, yeah, f of x is going to be 3x minus 5. Notice we're still working with the same functions, and these functions will be given to you. You do not have to come up with these. So now we're going to find f, the function of f, given the input of g of x. And so I'm going to write the function f of x, and in the place of x, I'm going to write this function, 2 minus x squared, in its place. 3, because this is what I want you to see. Where that x is, that's where I want g of x to go. And whatever we determine that g of x is, which is 2 minus x squared, that's what you need to be putting in there. And let's evaluate it. So I'm going to do 3, 2 minus x squared minus 5. And I'll have, don't forget distributive property, and I'll have 6 minus 3x squared minus 5. And make sure that you're combining your like terms. You have a positive 6 and a negative 5. And so your f of g of x would be negative 3x squared plus 1. Alright, now let's look at the other side of this. Let's see if we can get it all on one page here. Let's do g of f of x. Notice I'm going to get my function for g, 2 minus, and this is important. Make sure you put this in a parentheses. I'm telling you from the voice of experience, you'll make a mistake. Now put in your f of x right here. And don't forget to square it. So now I have g of f of x. And I'm going to say 2 minus, I'm going to open up a bracket here. And I'm going to put, what was f of x? 3x minus 5. 3x minus 5. Close my bracket. And make sure I square it. Follow my order of operations. Now, make sure you distribute that negative as well, but I'm going to take 3x minus 5 down to the bottom, because I'm going to multiply those two. I'm going to square it, that's what I'm doing, and I'm going to get 9x squared minus 30x plus 25. Alright, if I take that, and I now have 2 minus the 9x squared minus 30x plus 25. Now I have to distribute that negative through each one of these, so don't forget that, because you'll come up with the wrong sign if you don't. Alright, 2 minus 9x squared plus 30x minus 25. Now put your like terms together, and you'll get negative 9x squared. And I'm rewriting these to make sure they're in standard form, which is that ax squared plus bx plus c. So I'm just reordering them. I'm just using that commutative property of addition to reorder them. 9x squared plus 30x. If I have a negative 25 and a positive 2, I have negative 23. And so this is your answer to this one. Oops. And here's the answer to this one. So this is this one right here is your G composed of F. Over here you have F composed of G and evaluated at X. And you're evaluating it for X. In the problem that we had before, we had a value right here in the place of X, right here. We had a negative 2 there, but this time we're simply evaluating it for what the function is of X. And so that's why you have that variable left in your answer and not just a number. You're not just evaluating every x for a number, you're just finding that function for x. Alright, let's do the next one. Let's do 27. And let's do f of g of 2. And this one said, from a graph, you're trying to find the function given the input of x equals 2 for g. So when x, and this is on, and they give you two graphs on this page, I think it's on page 196, 197, this is number 27, where they give you a graph for x and a graph for f and a graph for g. And they ask you to evaluate it, the f of g of 2. So when the function for g is 2, what's the value for the function at f? And that's going to be 4. So when x is 2 on the function g, then x is 4 on the function for f. And that kind of goes back to that whole idea of x squared is equal to the square root of x. Okay. Let's do one more. Let's do like 37, because this is f of x, and they're saying and they're going to let f of x be 1/2, and we're going to let g of x be 2x plus 4. And so here they wanted you to find the f of g of x. And you can, look in your book and look at problem number 37 and see where I'm getting that f of x is given to you as 1 over x, not 1 over 2. That should be 1 over x. Sorry. And then they give you g of x as 2x plus 4. And so if you're evaluating f of g of x, then what you're really doing is you're saying 1. Remember, we're only substituting g of x in the place of this x right here. So let's put 2x plus 4 right here. Now, here's where you have to be careful, because when you substitute something into a denominator, then you have to make sure that you determine your domain, and x cannot be -2. And remember that x has to be greater than 0. If you had something in a square root, then you know that x would have to be greater than 0. So here, this would probably be the most important indication of what x cannot be. Because if you had a -4 and a +4, that would be 0. And you know that x cannot be -2 and x cannot be 0. So keep that in mind when you're talking about domains. Now let's find g of the function f, or that's the same thing as g of f of x. So let's get the function for g, which is 2x plus 4. And let's put in the place of, we'll put in the place of x, the f of x plus 4. And what is f of x? It's 1 over x. So we have 2 times 1 over x plus 4. And if you simplify this, you'll have 2x plus 4. And you have to make sure that you define that x cannot be 0. Okay, there's several problems there, and I think that these will help you, so I'm going to end this video here and post it for you to look at. Let me know what you think.